Hi, Ronnie. By the way, is Ronnie pronounced correctly?
Yeah, yeah, perfect.
How are you doing today?
No, no complaints. Everything is great. Just very busy Monday as usual, but
Yeah, in my case, it's also very busy, but it's unusual in summer to be as busy as now. So it's just crazy. But back to the real world. What
mhm.
was your first computer?
Oh, it was an XT, obviously.
Atari?
And no, no, it was an IBM compatible XT.
XT or ST. I thought ST. Okay,
No,
XT. IBM.
yeah. And I remember just the joy of just typing something into the command line and feeling like a total badass, just seeing, just running a simple dir command as a child made me feel like I was a major hacker. So it was pretty
Unusual that
awesome.
you started with IBM straight and not, C64 or ZX or something like that.
Yeah, I guess it was way back, and my grandparents actually had that computer, so I kept staying over just so I could play around with it. And then eventually they just gifted me the computer, and that when I got started. And then I actually got into coding very early as well because the potential of what I could do with this thing just blew my mind. So I started writing weird games in BASIC and things like that just to learn the ropes, and had tons of fun.
So you didn't play it? You just right away started, to code, or you wanted to code?
Uh, I definitely started playing some games, but then I remember I was looking at this amazing game that I really liked. It was a strategy game called, I guess, Sword of Aragon or something like that. It was just a very simple game, but then at the end, it just said written in Quick Basic.
Oh.
And I was like, yeah, I can do Quick Basic. What do you mean it was written in Quick Basic? And that's when like the magic or the kind of the illusion of the complexity of writing games just went away, and I no longer had the fear of trying it, and I started trying to write my own strategy games. Granted, none of them was really that great, but I had a blast working on them.
What's interesting that you started to play one game, then you saw made with Quick Basic, and
Uh-huh.
then you immediately started to code, right?
Exactly, exactly. Because I by then I was I knew a little bit of Quick Basic, and just the fact that I could, it's something I already know how to do, and all that stands between me and making a great game is just effort. Well, that sounded easy, so I
Mm-hmm.
immediately got started on it.
But immediately, you knew already how what for loops are, if statements. How you learned that?
Well, I had these booklets for learning basic that were in my house. I don't remember even who bought them. And out of curiosity, I was playing around doing the obligatory tutorials of making a Pong game or making it was all weird loops and go-to statements and nothing very complicated. It wasn't anywhere near the complexity we have in code today.
Mm-hmm.
But I already knew something about programming, and for me, that was like a big icebreaker. That yeah, if I know that, and this game was using those same if statement and for loops, then what's the problem? I can do the same
Okay,
thing.
nice. And there were no problem with graphics as well because they are harder, or was that a text-based game?
That took more time.
Okay, this is what
The
I
whole
mean.
idea of, double buffers and
Mm-hmm.
starting to hit the constraints of the resources of the
Mm-hmm.
machine. Um, and again, it's not that I did something too complicated, but I got started just, writing some text games, and then I upgraded myself to think about graphics. But still, it was I think there's kind of like a magic to it. I'm really nostalgic about these days when you're just sitting, in your room as a kid, and just the vast potential of what you can create is kind of amazing.
Yeah, vast potential in somehow incredible machine, right?
Mm.
Without boundaries. This also magical moments, as you said. Yeah, and now it is even more magical machines, but with less magic, right? Because somehow I don't know. they are just too complete, right? Everything is already solved. Seems like back then, everything was possible, and yeah, this is maybe the difference, right? So now we have great apps, and back then there was almost no apps. So, and we imagined that you could do, I don't know, some crazy Star Wars or Star Trek stuff, with the PC. This was maybe the difference, right? And now everyone knows what's possible, maybe.
Yeah, you're right. It was more of an age of discovery. And now that everything is already charted, there's
Hmm.
maybe less magic about it. I think I felt a little bit of the same kind of sensation when VR apps started appearing, because there was the same feeling of experimentation, and a lot of
Hmm.
indie developers created these experiences where they were kind of
Hmm.
finding out what the limits were and what they can do, and discovering new metaphors for UI and interaction and all of that. So I guess I felt some of that when I was kind of following up on that trend and experimenting with it myself.
Hmm.
Um, but yeah, I love those. The happy '80s for me were
Yeah.
a great time to be a kid.
Yeah. And this all happened in San Francisco, your quick
I
basic
don't
time.
know. I was in the East Coast at the time.
Ah, okay.
Where,
Okay, interesting. Because right now, you said, it's a beautiful day in San Francisco. So I thought, okay, maybe you also grew up in San Francisco. Interesting. So what happened after Quick Basic time? So you switch to another language, or you stick with Quick Basic? So after your gaming experiences.
so I think just learning or being having the orientation to write code opens up a lot of doors for you, because you're instantly kind of less afraid of it, and it becomes kind of a second nature.
Hmm.
So I did some coding in school as well. Like the fact that I could get graded for a coding exercise to me was a joy. So yeah, I could do what I like and get grades for it, and kind of it would count as schoolwork. So that was great. I did some coding in school, Turbo Pascal and all
Hmm.
sorts of other things. And then when I first got started actually writing code, it was .NET and then Java.
Oh,
Uh,
why .NET for? Oh, .NET because of your basic background, right?
uh, I I don't recall. I think I was kind of interning at a company and they were using .NET, so I just learned that back when I was in college. And then I got another job at the place where they were using Java, but it was nothing like the Java we all know and love today. It was the days of J2EE and
Oh, this are my days. I like J2E, so I did
yeah,
J2E and Java E.
and enterprise Java beans and all sorts of
Uh-huh.
things that were kind of making it was very complicated. And I all I
Which server
remember,
you used back then with J2E? Was it WebSphere?
I think it was JBoss, I guess.
Okay.
But I just remember a lot of XMLs and hard configuration experiences, and um, you know, looking at logs, trying to find out things was very, very difficult.
But this is
Uh,
strange because JBoss and XML. So usually, this XML was at the very, very beginning. And
mhm.
then since 2006, we got annotations. And prior to 2006, I used a tool called Xdoclet, which was basically a Javadoc based generator because I really didn't like XML at all. So I try to avoid that. So and then annotations happened with Java 5. So from then we got there was no XML. So this was actually interesting that you still had to do the XML configuration stuff. So was it after 2006?
Yeah, yeah, it was before. It was around 2004, 2005, I
Oh,
believe.
okay, this could be. So you didn't use Xdoclet then. You just
No,
used
no,
the hardcore XML experience.
it
Almost
was
right YAML right now, right?
it was terrible. That's
Yeah.
all I can say. It was a lot of XMLs, um, and a lot of boilerplate,
Hmm.
and somehow that was the impression that was kind of imprinted in my mind about Java, because afterwards I moved on to other languages, because I again changed jobs and they were using other things. And then when I came back to Java, I was kind of amazed by kind of the progress that was made and how, like, this is not the Java that I remembered.
Mhm.
It's something else.
And you studied something, computer science or no?
Yeah. So I studied computer science,
And you learned, which languages you learned during your study?
Java, as well as, like, Java was the first
Okay.
language. Then, Scheme and Lisp and other
Okay.
scientific languages as well.
What's interesting that you learned .NET first, because .NET came after Java. So this is what interesting. So you started I don't know, I would assume around 2000, right?
hmm Uh,
And
I,
and .NET happened, I think, after 2000, right? It's like 2003 maybe was .NET on the horizon, and Java is already there. So Java was pretty old. So I would say 7 years or something like this. And you
mhm.
started with .NET, and then you switched to Java. So this is back to Java. It's a really unusual trajectory.
Yeah, yeah. I switched a lot of programming languages over the years. I think, like, the language itself to me is not that critical or
Hmm.
important. And I had the chance to work with teams on very complex applications in Python, in .NET, in Node, in Ruby, in
Hmm.
Java, and it's these are the same problems.
Hmm.
Managing complexity is
Hmm.
hard in all of these different languages, and scalability is hard in all of these different languages. And in a similar way, today when I'm hiring developers for my own team, um, I actually don't quite pay a lot of thought to or put a lot of emphasis on the background in terms of the programming language. So, for example, we took somebody on who had experience in a completely different programming language, um, because ultimately, I guess what matters more is kind of the your problem solving skills and how coherent you are in kind of solving those problems, and how readable your code is, and how familiar you are with some of the patterns and ideas that you need to know in order to solve these problems. And the language is a technicality to some extent.
It is
It
interesting because
can get into
I have
but
different opinion because yeah, no, I'm with you with language. It doesn't matter. It's just syntax. But
mhm,
I just stick with Java. And
mhm,
what's if I would try another language? I can learn, I think, fast other languages. But in Java, I already know the problems. I know how what happens if I do this. So I'm quicker in problem solving.
mhm,
Because if I see a context, an error, exceptions, I can immediately know what to do. And this is not. I'm not talking about syntax errors. It's more like JVM errors, or what happens when a JVM is overloaded. And I would use different language. What will happen is I would always assume the problem is on my side, and I would try to fix my own errors, even if the problem is on the runtime JVM, so or cloud or whatever. So I think there is a huge value in sticking to one environment ecosystem, and not
mhm.
switch back and forth, because language doesn't matter, as you said, but the ecosystem does.
So I have a counter argument to that, and of course I agree with what you say. I think there is a lot of merit to it, but at the same time, one of the most in one of the things that influenced my thinking the most was actually changing the paradigm a little
Okay.
bit in my coding. So, for example, I was using very static languages. I was using .NET and Java, and then I started experimenting with Ruby and Python.
Hmm.
And I learned a lot from that. And I carried over a lot of that thinking and learning back to .NET and Java. And I started back in the days writing libraries for testing in .NET that more resembled maybe RSpec in Ruby, or that more resembled um, Cucumber, and it was
Hmm.
before those were available in .NET. And this is because I was kind of learning and seeing and maybe copying sometimes in the DSLs that I was creating as well for solving different problems. Um, things that I've learned and that I've kind of valued
Mm-hmm.
in the other languages and paradigms into my own, world. And I think this is extremely important for developers to do. I
Yeah,
think,
I agree with you about the paradigms. So I think you should take a look what the others are doing, right? And think about the paradigms. But I have to use JavaScript as well for the front end, for instance, which is dynamic. So is and this is already have some experience with completely dynamic language and with static language. I think there's not enough time, to learn two main languages. This is a little bit my problem. So no, if but yeah, this is just a side note. What also interests me, which projects were you interested back then? Is this was like an enterprise project backend? Because what was the JBoss project about, and what was the next project? So you are a backend guy, or what was your ideas back then, or your interests maybe?
so I find that I kind of went through a lot of journeys and changes. So I was a backend guy, and then I became um, a front end guy for a mobile app. So it was kind of the back end and front end of
Okay.
mobile. I was actually writing for Java mobile applications, J2ME, as well as
Oh.
uh, a compact framework in .NET for a
Mm-hmm.
while. Then I came back to back end development,
Mm-hmm.
and I did a lot of kind of domain driven design type architecture on large enterprise applications. Um, like everybody else, the kind of tried to wrap my head around kind of bounded contexts and all sorts of abstractions that were very unfamiliar to me at the time.
Mm-hmm.
But again, I think one of the things that I really feel fortunate, and I'm sure a lot of other software developers feel fortunate in having experienced, is that there was, in that sense, a lot of discovery as well in those years
Mm-hmm.
in terms of how to code and what works and what doesn't.
Mm-hmm.
Just think about how people were coding when I got started, and then moving to forward in time to today, where there's continuous integration and continuous deployment and um, different kind of understanding about how asynchronous flows should work and promises and how to scale horizontally and all sorts of things that were just we were discovering them.
Mm-hmm.
And the same goes for practices. I started in a completely um, non-agile kind of waterfall process, and the organizations were learning how to do agile, and we were
But
learning.
what was it not obvious to you that the waterfall doesn't work? Because from the beginning, the entire UML, and unified, how it's called, the rational unified process, and whatever we did back then, for me it was it's like maybe there are smart guys out there which who are really able to follow this. But for me, I always cheated and always was, had the small iterations. And at the end, I drew the diagrams and just, shipped everything. So it looked like waterfall, but was actually just, I hacked down the code and created the diagrams afterwards. This is what we did from the beginning. So,
I was
yeah.
I was not confident enough, I guess, at the beginning because I stepped into a position as a developer.
Mm-hmm.
Everybody else had opinions about like how development should look like with PRDs and MRDs, and I don't even remember all of the different acronyms. And all I remember is just how documentation focused everything was.
Mm-hmm.
Um, and in all of that process, it was kind of accepted and accepted truths that this is the way to write software. And I guess they were modeling things from other industries that this is the
Mm-hmm.
way that
Yeah,
things
exactly. From building
where
fighter planes or rockets or something, right?
exactly where it's very hardware oriented and you can't go back and change or iterate it. It doesn't kind of work
Mm-hmm.
that way. Um, so it was very hard to think about something else at the time. It was obvious that things were not working. We were always kind of missing deadlines and being late,
Okay.
and then changing requirements and being later, and all of the pains that I guess now many of them are solved in modern practices were there.
So you saw different languages and you code a lot. So meanwhile, what I thinking is the path to success is write very simple code. And simple means how to call it, purpose driven, right? So of course not too simple. It has to work somehow, and try to write obvious code. So code which reflects clearly what you are thinking, and then constantly try to improve the code. So if you see okay, this is simple, but it doesn't work, so I would just improve it. I think this is the only thing which works. So how I got, I mean, you mentioned the bounded context. This is how I got the idea, because the bounded context, if you copy something, is okay. This is, and then you can afterwards try to find out whether the entity should be factored out into a single entity or two copies are enough. And I think if you do this, at least in Java, so this is my background, or JavaScript, you are already good, because it will be easy to maintain. But you should always try to improve. Remove redundancies, rethink, review your own code, and this is, I think this is the only recipe to success, or not.
I guess what you say really resonates with me in terms of architecture, or should I say over architecture, that was maybe the next phase as a developer, because after we got started on these different ideas like domain driven design, and other concepts like CQRS and event sourcing and all sorts of patterns that we started working on. There was a time where we were very much over architecting everything, and kind of maybe making things much more complex than they should be, because we followed a lot of structures that were obvious to us, and creating hexagonal architectures or what.
Hexagonal architectures where only two protocols were given. This was the typical Java, hexagonal architecture, and we only had JAX-RS. But I say one day you will see we get WebSockets, whatever. It's like, but now we just have REST.
and using complex tools like there was one video that really influenced me as a developer. I can't remember the name of the person who gave the talk. I think, but the topic was simple versus easy, and he was basically talking about what's the difference between the two, and how oftentimes we choose the easy solution, but it's not simple. It just creates complexity. And I guess for me too, over the years, I've learned to value simplicity much more than other values in coding, like maybe reusability, like maybe modularity. And adding layers of abstractions is easy. There is nothing you can solve by adding another layer of abstraction, as the saying goes. But there is a cost. There is a big cost to abstraction. And when you learn the cost, then you know when to balance it out. And maybe you don't need to use Hibernate, even though it gives you the ability to change the database each time, because maybe the database is important. Maybe you need to create an application that runs simply and effectively on one database.
Great example. Hibernate or JPA, right? So if I will build CRUD, create, read, update, delete right now with Hibernate or JPA. So this was the simplest possible code, because I would have an entity with two annotations and an entity manager. But and the next requirement, if I see really complex query, or some batch processing framework, you can always throw away JPA, remove the annotations, then you have your data object, convert it to a Java record, and for instance go with JDBC, right? This is but if I would start with building my own ORM, my own one, then I have 20 layers of abstraction, and then it's really hard to use something different, because you already invested in 20 layers. But if I invest in a simple JPA entity with 3 annotations, then it's just very easy to move away from it, right? So this is you are exactly right. Perfect. So we are almost we share the same same ideas, which is unusual because usually I have lots of discussions regarding modularity and I'm building monolithic code and why I'm not using interfaces or the craziness in Java. I don't know whether you remember that you have interfaces and implementation with impl. I say, why are you doing this? Why are you calling everything impl, right? Or interface with I mean, I see it as an interface.
And this is, by the way, an example of when I switched between Java and .NET. I could see that, hey, wait, in .NET we're not doing it, and it's clear. And then I ported that idea back to Java. So it's kind of that exchange that I think is really productive for developers, because it allows us, like the developers in my team who have more a wider range or wider gamut in their experience. It doesn't even need to be between programming languages. It could be somebody who has some experience in DevOps, or somebody who has experience in QA thinking, or somebody who has experience in other fields altogether. So that you can kind of bring and make relevant in your coding. So
I'm a little bit cautious with the polyglot programming, because in one of projects last year I reviewed a project, and I think there were like 20 microservices and I think more than 6 languages. So what I remember, there was Node.js, TypeScript, Go, Java, 2 flavors of Java, Quarkus and Spring, and Groovy. And I asked them, why? But say because of polyglot, and no one understood, the entire thing. And then we agreed to Quarkus. Now it's everything Quarkus. I mean, it is maybe some developers are not happy, but it is simple. Everything is the same. You can look at every microservice and you understand everything. So this is why I'm a little bit cautious with polyglot, because it sounds like a best practice. Just pick, the language of the day and go for it. But what do you forget? If you have 10 languages in the project, I mean, there are almost no developers who understand everything at once, right? So that's the problem a little bit.
Definitely. And I guess this kind of led to the next challenge that I encountered, which is, there was at that point a big trend towards continuous deployment and towards releasing faster and faster. And at that point in time, I realized something that was really troubling me. And that was that we were essentially releasing faster in my team. We were doing everything we were told, but it kind of felt like all we were doing is kind of throwing features over the fence at a higher velocity or, faster intervals. And this started bothering me, because I was noticing that, somebody would take on a task, they would develop it, they would write all of the tests and everything, and then they would merge their PR and move on to the next task. And there was zero learning in terms of, from the very basic questions like, is this code running? And did I miss something in an if statement? Is anybody using it? To, did it improve life for everyone? Is it scaling? Is it working as intended? And it seemed to me what we replaced feedback with was essentially alerting and monitoring, which to me was not very effective, because it seemed like it was very reactive. I sometimes, in my team, jokingly called it BDD, but not behavior-driven design, but bug-driven development, because essentially we would get a bug, we would get an alert, and we would fix it, then on to the next one, and it was not sustainable. And this is kind of what got me completely to rethink the whole paradigm around feedback. And when I looked at kind of DevOps loop models and all of that, it was obvious that, the DevOps loop didn't have an arrow going in one direction from code to prod. It also had an arrow going in the other direction. And sometimes it even said continuous feedback on it. But I could not find a tool that would actually allow that to happen. So
there are more problem with, right? So I would say, if you, from my Java experiences, first the lack of rewards or even stats, for end-to-end tests. So in Java there is lots of how to call it, focus on unit tests, because it is the easiest to get code coverage. But if you look at a microservice, there is the unit tests are absolutely not that interesting because they are just testing the basic algorithms and never the system from outside. So if you start with system tests, the large companies are no more that interested because the statistics are no more visible to management, and they say, I don't care about that. I only need code coverage. 80% of unit tests, I'm happy. So, and the next thing is monitoring on observability. So what happens is, the developers either they write, interceptor, and they just say this method was fast and the other was slow, so it is pointless. Or you get the entire JVM metrics, which is even worse because you see, I was actually in War Room and they showed me the garbage collector. I said, okay, who cares about that? I mean, yeah, we can look at this, but no one knows what's going on here, right? And what I say the simplicity is focus on what's really important in projects. So what I do in Java, so we design packages with business names. And these packages with business names are like large entities, like large domain objects, right? So you would find shopping cart, I don't know, addresses and invoices and stuff like that. And what I just say is I would expect at least one gauge or counter per such package. So if you have the concept of shopping cart, I would just like to see how many items daily are stored in the shopping cart, just the basic metrics, or how many shipping orders per day we have, and then try to learn from that, and then we can detect anomalies. So if there is one day where nothing happens or too much happens, so we see this, and the basic counter in Java is just one method with an annotation, so there is actually nothing to do. But still, this is really hard to convince the projects to do this. Also, there's almost no effort, and the worst back then was Hystrix, for instance, right? I don't know whether you remember. So it was in every Java project, and I asked the consultant why we have everywhere the dashboards from Hystrix. I say, yeah, because it looks professional. It's like, yeah, it looks professional, but it's pointless. I know all the diagrams. I just see the technical stuff from my projects, but not what's really going on, right? So I would say every concept which is significant has to be exposed as a metric. And the technical details should be hidden. And afterwards, I can look, during debugging phase about JVM and hotspot behavior and whatever. So this is what I'm doing, and I'm just wondering. This is just obvious, right? So if you have a car, you also see, how fast the car goes, and know how, I don't know, how hot is the oil somewhere. Who cares about that, right?
So I think the two things. First of all, you're absolutely right that often we have pretty dashboards that are useless. And I've seen this happen in multiple organizations where they just have these fancy LCDs and these nice dashboards and nobody's looking at them. It could very well just be a static picture, but it looks nice. But then I want to tell you something that happened to me a few years ago, where I had one of the developers in my team introduce a log message, and was a counter. He was basically working on a background process, and he was just logging how much time the background process took to run and kind of take care of all the jobs. And the reason he was doing it is he was introducing code changes. And to him, unlike any other developer in the team, he had kind of this sense of ownership that he said, I want to know the impact of my changes as I'm writing them. I don't even want them to, later I'll monitor if they're in production, but I want to see I'm adding some queries, I'm using different strategies. I want to see what's going on. And of course, he was spamming everybody with the console out messages, and that was kind of maybe funny to talk about later. But to me, it was also an indication of two things. First of all, that he has that sense of ownership beyond just doing his task to make sure that it runs and it works well, that I'm looking for in developers. And B, that he was using the absolute wrong tooling in order to do it. But the tooling is fixable. And the fact that we can actually rely on this type of feedback during development, that realization really started to pique my interest as a developer. Because to me, that allows us um, maybe to shift what observability into a more continuous mode, which is what he was doing. So I was recalling testing, and testing when I got started was not continuous. So kind of wrote tests, and if you were kind enough, you ran them. And sometimes you didn't do it for a while, and then you tried it, and it was not working, and then you had to kind of fix everybody's mistakes that were accumulating for a while. So the premise was maybe we can do the same with observability. So maybe we can create a situation where my team member would not have to write a console log and kind of keep track of it, or even have a dashboard that he would kind of keep looking at to see like the effect of his code, but to have that automated somehow.
Mm-hmm.
And
Interesting with the logs, because, for instance, if you're on AWS and you write, a log in specific format, it's called EMF, embedded metrics format. The cool story is it automatically creates metrics from it. So this could be anti-pattern, which becomes a best practice. But outside on premise, what I'm doing, I'm just using Open Metrics and Prometheus, for instance, because usually, Prometheus is running, so that for static gauges, it is working. But back to you. So you move back and forth. You learn different languages. So you spend some time and with J2ME and .NET. And what happened then? So what else it is. By the way, were you always freelancer? You work for a company or?
I was always kind of employed.
Okay. As a
And
consultant, architect, developer, or what was your?
I was a developer, then a team lead, then I was a line manager, then I was an R&D manager for a while. But I didn't like the management aspects that much, so I kept kind of crawling back into the code. I guess another kind of vertical that I found myself oscillating on is kind of the product management versus development side, because as I was writing code, I was very invested in kind of, okay, why am I writing this? What is the use case? So I became a product manager for a while, and then I hated the fact that I wasn't coding. So I became a product manager who also introduces code into the code base. And then that became a problem. So I was kind of oscillating back and forth, trying to find my balance in a way that would allow me to both care about the why and how, stay involved in the technical implementation and write code, and ended up doing all sorts of positions with made up names that just allowed me to balance these things. Until eventually,
What was the best made up name? So you came up with
Director of Enterprise Architecture, was it? Or
this was a cool name, Director of Enterprise Architecture.
yeah, I think I came up with it. So yeah, I worked at a great company, and they were really trying to also allow me to fulfill my potential. So they were really great about kind of trying to help me find a spot where I would, not feel that I was frustrated because I was lacking, involvement in product or involvement in code, and then later in other topics as well. So I was fortunate enough to be able to find positions that allowed me to balance all of these different aspects. But there too, by the way, from the product management perspective, I was a bit struck by the gap between the amount of tooling for feedback that I had as a product manager. So think about, I'm not going to name all of the commercial toolings, but just, Google Analytics and other kind of tools that just give you so much feedback from a product perspective about what's going on and your designs and your ideas and all sorts of things that you can derive from the data, and a lot of tools to analyze it and to give you data or conclusions and insights to use in your work, versus the developer that doesn't always have the equivalent of Google Analytics for code or for the technical areas.
This was your realization, your observation that we have almost nothing in code, and there is something out there now for everything, right?
Yeah. So and as I looked more into it, I saw that there were reasons for it. So all of the APMs were created for DevOps originally, and IT, and monitoring and alerting. These were the use cases they were used to. So the teams themselves, the engineering teams, even though I tried to get them to, work on the, collect data, use because it's not a problem of not having enough data, especially today, and there's open telemetry, and there is a lot of amazing work that the micrometer team is doing, and there is plenty of data out there. But what got to me was that developers were not actively using that data when they were developing code. Just like my team member who added that console log to track performance, but he was kind of the exception to the rule that kind of highlights the gap here. And this is something I started looking into very seriously because it was impacting me in as a product manager, because it was impacting me later as a developer. I was trying to figure out why that is. Why are developers, and we call ourselves engineers, which has a very scientific feel to it. So let's be scientific. Why are we not using more data in our work? I just rolled out, I don't know, a new upgrade to the DAL or whatnot. Why am I not testing its impact right away? Why is it moving to the next task that it seems obvious should be the next thing to do? And this is what I started looking into, and what I found out was that there was a problem that it didn't happen automatically. And just like testing, if it doesn't happen automatically, it probably won't happen. B, there was a big expertise gap in the sense that, this data is hard to work with. Even if you look at graphs and statistics, you need to at least understand some basic statistics so that you don't pick up like an outlier and start getting to weird conclusions. It takes work and it takes effort. And it's often outside of the comfort zone of many developers, which is why it's kind of not that intuitive that it's happening. And at the same time, I noticed something else that was frustrating me, because I was looking at OpenTelemetry, which is a pretty new technology, and at first I was kind of ecstatic about it, changing the playing field completely. But if you search up OpenTelemetry in Java, for example, somehow all of the results that would come up would be about how to enable it, how to start, tutorials, getting started guides, all of them sponsored by vendors. And there is not a single article or blog that tells you, hey, the goal is not observability, it's improving your code. And here's how you can actually use that data over there. Here's some practical ways you can use the data, the metrics, the traces, all of that, in order to write better code, or in order to catch issues earlier, or in order to understand how your code is being used in various environments. This is what I was looking for, and this is what I was not finding. I think the only exception, and I really need to give a very warm shout out to Jonathan Ivanov and Marcin from the Micrometer team, who are actually promoting this type of content and trying to get more practical example out in the field. But other than that, if you look at the kind of landscape with all of the enthusiasm going on about observability and OpenTelemetry, most of it is not something that the developer can use or translate into something that they would do in the day-to-day. And for me, this was something that was almost kind of unimaginable. Like, how could we have so much data on the one hand? How is it that we're at an age where we made great leaps forward in terms of observability, and we have all of this technology and data, and on the other end, we're using so little of it when we work? How do we bridge that gap?
What you did about that?
So at first, I tried to implement different ways to work with the data myself and my team. And it always came out short. Some of it was cultural. People were kind of, that sounds like, complex things that will just generate more work for me. I'd rather do something else. And some of it was the complexity of the data, because, take tracing, for example. You can look at an individual trace and it tells you a lot about a single request, but without starting to aggregate and running some basic statistics on it and understanding different properties around, anomalies and kind of changes that you can identify within the trace, it's very hard to make it into something that I can say, oh, this is my code change, and as a result of that, the things are X% slower, or I created a bottleneck for other processes using it, or maybe there's some anti-patterns that we can detect here. And
So my
eventually,
idea was with the business components of packages to expose some business metrics. And your idea was to drill down then, right? So what I would identify is, okay, I don't know, there's something problematic going on in the shopping cart. And then your idea would be to drill down there and link, the open telemetry data, open tracing or whatever, and try, to calculate the average first and say, okay, this code change, lead to an anomaly. And now is something wrong with this code because before this push or before the deployment, it looked good. And now, with your change right now, something happened here, right?
yeah, so definitely. My vision is to be able to get to a state where we can do two things. A, that as we code, if we create an issue, if we somehow, I don't know, reference a lazy hibernate attribute in rendering our view and we create a session in view anti-pattern, or if we create an n+1, or if we cause a new type of exception, or if we add any type of regression, then there would be something there that would be automatically looking at that data
Prior
and
to
telling
deployment.
us proactively as we're writing code. And then
Okay.
the other aspect of that vision is that if we already collected information from production and testing, that we would be able to look at any piece of code and say, how is this working? Is this working well? What are some scalability issues it's facing? Where are the weak spots? What are the top things we should be improving about it? So basically give, on the one hand, shorter feedback loops, and on the other, and just give more feedback to the developers that would allow them to own their code. Because today, my code ownership ends when I deploy. If I don't do something else. And
So your
code
experimentations with your team were not well received, and then what happened then? So you started, to focus more on a product, or what happened then?
So I got to the conclusion that it needs to be automatic. We need, just like we have a continuous integration pipeline that is automatically and takes our code into production, if we don't have a continuous feedback pipeline or some kind of arrow that goes in the other direction that just automatically always collects information from observability and gives us back that information in our tooling and IDEs, then it won't work. And this is why I started a company called Digma. And Digma is
So
just
you
a free
stop your work, then you say, okay, developer is not with me, and then you started a company, right?
Yes.
Okay, interesting. When was it?
Almost a year and a half ago.
Oh, okay. Interesting. So it's a startup, right?
I actually I was talking to a lot of entrepreneurs afterwards, and it was funny because many of them had this whole, I'm going to go through an ideation phase, and then I'm going to think about what's the right idea that I want to do that would make me the most money, and how do I raise funds for it. And for me, it was the opposite. I was just like, okay, this is kind of an evolution of my thinking as a developer. Somebody needs to build this. Let's go get feedback about it. And there is a saying about VCs that when you come for money, you get feedback. When you come for feedback, you get money. So it was absolutely the same. I came for feedback. I got some money so I could leave my day job and start working on it. And my number one constraint, though, that I was very clear about in the beginning, it needs to be free for developers. I'm not, even though there's going to be people spending time, it's not after, if developers shouldn't pay for their dev toolings. Organizations could, but developers shouldn't. And this is where we got started on Digma, and we assembled a small troop of beta testers, all friends, and we said, hey guys, we're going to try and iterate with you in a very agile way. and kind of find out what can help you in exactly those use cases and scenarios. What can help you when you code to get more indications about how your code is working, and what can help you from the data that we have out there in the field about your code to understand more about the code, especially, by the way, if it's complex, if it's not yours, if it's legacy. The more opaque the code is for you, the more you need more transparency, the more observability can help you actually understand it, from who's using it, who might break, to what was the behavior before I made this change, and what is it now?
Is it already working right now? Is it usable?
Yeah, so we created it as a plugin for IntelliJ for now, because we're kind of working our way through different platforms and IDEs. Java to me was the first language. So
That's what I wanted to say. After all your experiments with Ruby, Python, whatever, you found old love, Java, and you say Java is the one I have to start with, right?
Yeah, there were several reasons for it. One is it's always the people, right? One is the people, because I met such an amazing community that I really kind of internally I had the urge to work more with them. And I was at the time we were starting, we didn't decide to start with Java when we just started Digma, and at first we did some Python and some Node and some Golang and other languages. But then eventually it kind of came down to where we were finding the most interesting and interested people that would kind of, and it didn't make sense to start with a kind of supporting many different languages, because it just meant we were detracting from the value that we could give each one. So we decided, let's pick one language and be great at it, and see how we can, and pick the community that is best, that has the most willingness, and also that we like working with the best. And this was Java, kind of hands down. We went to a lot of conferences, and I guess I went to Dev Nexus a while back in Atlanta, where it was kind of made completely obvious. Yes, because all of the other places I was talking about the technology, and they were like, politely curious, as Americans often are. They were kind of smiling, but not really committed. But in Dev Nexus, I just went around randomly talking to people, saying, "Hey, I have this idea. What do you think? Do you want to take a look at our booth?" And they were like, "Oh my God, of course! I'd love to give you more feedback." And this was kind of a different attitude, I guess, from the community that we received there. And this made it very easy to decide, what, let's double down on Java. Let's make the best Java kind of developer observability thing that we can do.
So absolutely. What happened is, right, I got a message in the AirHacks Discord server. There's an interesting project, you have to talk to them. So this was a Java developer, of course, maybe he met you and DevNext or whatever, and I say, okay, it looks interesting. So I ping one of your developers, I guess, and they say, okay, no, I have to talk to you. I'm saying, no, now we are talking, right? So it's an interesting project, let's do it. So I have no idea what you are doing, but I'm really glad, because already it was really interesting conversation with your background, complete different to mine, I really like J2E, Java. You didn't like it at all, but we still share, some ideas. So it's really interesting. So there's a plugin to IntelliJ. So right now I have IntelliJ Toolbox. I use mostly Visual Studio Code, for instance, because I have to also do lots of JavaScript front end, and Java is just fine. Also I use Maven, so it works perfectly with Visual Studio Code right now. And what I misunderstood prior, it is not about open telemetry. You are applying more or less machine learning, right? To find patterns and compare it, with best practices, and try to predict what happens when you write this code. Then maybe this and this will happen, right? This is and what I also understood is that you are able to learn from your production experience and apply, the experience from a single production project to reapply it back to the code base, right? This is what I understood.
So not exactly. I kind of look at it from two different directions. On the one end, we wanted to completely remove this whole open telemetry or observability language from the equation. We approached developers. We told them, hey, we have this open telemetry thing. They looked, yeah, it's exciting, but it sounds complicated. Maybe you should talk to our DevOps. And then that's when we decided, okay, it should be a button. That's it. It should be a toggle button. I want to collect information about my code. And if we do open telemetry behind the scenes or something else, that's great. But as a developer, don't tell me how the watch works. Tell me what's the time. And we completely abstracted that part. You can, if you use open telemetry, you can send data to us. But other than that, it's kind of a very simple toggle just to enable and to start working.
So what are you doing then?
And then most of the challenge, as we discussed before, is not the data, is actually analyzing it.
Okay.
So what we're doing is basically we're collecting data from OpenTelemetry metrics, logs, traces, and so on. And we're finding out what it means about the code over time and with changes. So we can, as I'm writing code, we can do all of these things that I expected my developer to do. So, for example, if I introduce a code smell, if my code created a change in how things works, I should be aware of it at the very least. And sometimes if it's a big anti-pattern, I should also be alerted to it. So it's kind of like a living documentation in the sense that you can look at each piece of code and understand exactly how it's functioning via code lens, via kind of being able to double click into it and see more information and understand kind of what are the weak areas in my code, and especially regarding the code that I'm introducing right now. And at the same time, being able to collect information from production environments, as you said, or testing, and just have that visibility in my code so that I know, okay, and there are many different types of cases here. It could be, you know what, the most issues are in this piece of code, but in the testing environment, I'm doing nothing there. So maybe I should add some more tests. It's not even hit in that scenario. Or it could be, this is the code that I just rolled out. Let me see if it's being used. Let me see how it's working. And to do that, to get to that level where we're not just showing you graphs and metrics and data that they don't mean a lot. Like as a developer, is a high CPU good, bad? I want to utilize, a lot of CPU, but so is it good that I reached a high utilization or not? These questions are very hard for developers to answer, for me as well. So what we added was a lot of machine learning and data science around how do we reduce this down to specific conclusions that we can find out. The system is short of resources. This is something we can find out in production. Or this specific code has a critical section that's causing a scaling issue because everything else is waiting for this one piece of code to complete before it can move on. So this is kind of the thinking and analytics that we added into Digma, and the idea is to make that something that's very transparent for the end user, so that they don't need to worry about how am I going to start, where do I get started, what is the how do I start setting up micrometer or open telemetry or something like that. We just wanted to have this to try to overcome the aversion that many developers have to something so outside of their comfort zone, like observability.
What's interesting, there was the episode 49 of the Airhacks FM podcast, 2019, and I had a chat with an H2O developer, and I always had the idea, because if I do something, let's say, but not at runtime. So let's see, I have a REST endpoint, right? And I'm sending data to the endpoint. And if I know the data, an exception happens. So there is a direct link between, the input and the exception. So it should be possible with machine learning, to predict, the exceptions and just analyze this. And this, what you did, is very similar, but not at runtime, just at the code level. So that was the episode number 49. So it's really interesting. So this is what I always, try to do. So the machine learning, you can actually analyze the log file with the exceptions and try, because there's a direct link, time whatever, to the code and to the runtime data. So one question. So what I understood is you are linking more or less the commits to how to call it, to averages, right, on the server. So this is the commit cause this change, and this change. And over time, you get better and better in predicting, what happens. So if I start with the project, is there something like a seed knowledge, which I gain from the beginning, or there is a learn phase, 1 month until what happens?
Yeah. So if you start using Digma, you install the plugin. By the way, everything runs locally on your machine. So I know a lot of users are kind of wary about sending out data to the cloud. So everything is running locally. You don't need to send out information anywhere. You install Digma and you continue on coding. And then what will happen is immediately as you run your code, debug, test, and so on, basically generating runtime data, you'll immediately start seeing additional information. Some of it would be around, basic statistics like, this specific request, where is most of the time being spent? To things that are more towards trends. Since I started working on this project, I've been accumulating more data, and I've seen the data access speed decrease, or I've seen that maybe I should add an index, because every time I access this table and these columns, it's becoming slower. The more data I have in the database and so on. So the idea is that right away you get this X-ray vision about the code, because and it's just a reflection of analyzing the code, tracing metrics and logs. That's it.
So this is like we get with Digma a pre-trained model with some basic best practices, right?
Exactly. And not all of it is machine learning. We have some aspects that are machine learning, some aspects that are statistics, and some aspects that are just basic rule engine based analytics that just look for specific patterns.
But actually, all machine learning is statistics, right?
Yeah, but in this case, it's more basic statistics.
Basic statistics. Okay, I understand. One question about the button: how you get the data from production or from remote server? Not even production. Let's say I have a dev Whitefly. Let's say, right, a beautiful J2E server with lots of XML running. And the remote location, how you get the data, or what I will have to do to provide you the data?
Yeah, so the way we structure Digma is that you can start right away in dev, just to prevent any type of wait up for somebody to authorize to get data from production, which is often a big deal. So you can get started right away, running tests locally, debugging locally. We're even smart enough to know things like, this is slow because I had a breakpoint and I'm waiting, not because I introduced regression and things like that. We just, because we worked it out from the fields, we got a lot of hands-on knowledge and handling these type of edge cases. And then eventually you decide, okay, I should get some information from CI or from production as well, because that will give you more context about this code. And that's where you can run Digma anywhere, basically. If you want to run it like in your Kubernetes cluster, in some central location. And because Digma is just an OpenTelemetry receiver, so it's just an endpoint, just like you send Logs.io or Coralogix or, I don't know, Grafana Cloud or any of these tools. You can just send it to Digma as an endpoint, and it can run locally on your network, so you don't need to expose anything to
It's not a scraper like Prometheus. I have to send, the metrics to Digma, right?
Yeah. So basically, it doesn't scrape anything. You just, in your OpenTelemetry configuration, if you don't have one, it's very easy to add. And then in your OpenTelemetry configuration, just, you set Digma to be and basically a destination to send traces to. That's it.
And what added value do I get? So if I do this, would something change in the IDE, or I get better predictions and better suggestions?
So you start getting other context. So you start with the dev context. So this is everything we can learn about your code just in dev, just like the developer that's adding the console log. When you introduce CI, we also start looking at the CI, and it becomes its own section in the plugin. It tells you about, okay, what does CI tell me about this code? Is it even being hit in the CI? If it is being hit in the CI, what are some of the issues that it's finding out, and so on. And then lastly, when you introduce production into the mix, then you can actually visualize all of the issues that the code has around production and when they're happening and so on.
And another what interests me, so for developers it's going to be free, right? How you would like to make money? Somehow important, right? So I mean,
so the way that we set it up is that we said basically for developers, it has to remain free and be free at all times. If at a certain point an organization wants to install it centrally and have multiple users logging into the same instance, and they want to start, it becomes not a decision of the developer to use it and experiment, but a decision of the engineering team and the DevOps team to enable it, and so on. And then the organization, if it already sees it provides value, there is a share, like a fair exchange of value around, okay, we're using it, we probably need to pay for it. But for individual developers, even if they work in the organization, they can use it, and we absolutely value their feedback. We're actually happy they're using it for free.
Very good. Actually, I like I like 2 points. First, you can start, with your developer machine without sending anything to the cloud. So this is what I really appreciate. So this is an unusual approach, cloudless approach, which I really like. And the second thing, which I also appreciate, the endpoint stuff. So you have to send actively the data to Digma, and not Digma as a plugin, which listens to everything. So this is also what I really appreciate as a Java developer. So how much of Digma was written in Java?
Some parts of it, especially the ones that deal with Java, and some of the plugin for IntelliJ was written in Kotlin. And a lot of the processing in the plugin itself are written in Kotlin. Behind the scenes, around the microservices, we use everything from .NET to Python to other languages. Okay. Again, because of the libraries and tools we need to use. I guess when we got started, we wrote the very basic services in .NET. And this is where I was mentioning that I sometimes hire people that don't have the language expertise. And I actually got an engineer to be a part of the core team who's a Java developer. And at first, everybody was wary, why are you taking a Java developer to write .NET? But eventually, he became a major asset because he had a lot of experience. My Java was rusty by that point, and I was just coming back to it. So he was able to give us a lot of added context and around Java, even basic methodologies that are more modern than what I remembered, and toolings and so on. So It was great to have on board.
Perfect. And last question, how it was possible to create such a project in 1 year?
A lot of hard work, iteration, and feedback. Like if we didn't get feedback from the community, and I'm the first to say that we were wrong in many of the decisions we started out with, because even though I'm a developer and I'm writing a software for a developer, it was at first obvious to me, yeah, of course I know what to do. But then I talked to developers and I saw, not all developers are alike. Each of them have their own kind of nuances and the way that they look at the world and the problems that they're facing. And B, that I was wrong around many of my assumptions. For example, we found out that it's much better to look at specific opinionated examples rather than provide a generic solution. So, for example, look at top Spring anti-patterns, top Quarkus issues, and kind of give a lot of value around that, so that right away, if I'm a Spring developer or a Quarkus developer and I'm using Digma, I'm getting a lot of value right away. And this is kind of what we wanted to create, basically a different or just make it a non-issue. Of course, I'll enable this plugin and immediately I'll start seeing things that are relevant to my world, not to every developer out there.
Right now, lots of my projects are Quarkus projects. So I'm into, because you mentioned Quarkus. So is Quarkus popular in your world? So is there lots of Quarkus projects, or what's, because you mentioned already?
Yeah, so I guess the two most popular ones that Digma users are using are Spring Boot and Quarkus.
Interesting. Okay.
If you look at our community, I guess most of it is still Spring Boot, but there is quite some people who use Quarkus as well. In the beginning, Quarkus had its own issues with observability around the reactive mode and so on, but it was fixed and it's actually working great now. So I would, and we actually had to, we updated Digma to have better onboarding for Quarkus just to make sure that it plays
very
well.
Good. Because lots of listeners are Quarkus actually developers, and also in the Airhacks Discord server, also lots of Quarkus people, developers.
Okay. Yeah, and I have to hats off to the Quarkus team and Bruno Baptista and some of the other guys there who are really helping us get the best value for Quarkus developers and guiding us in a lot of what we're doing.
Perfect. So where people can try Digma, so how they should do it and how they can find you on the internet. So there's also
So
two questions.
you have two options. One is just go to digma.ai. That's our website. And there's a Get Digma button there that will just allow you to get the extension from the IntelliJ marketplace. You can also go into your IntelliJ and either community or ultimate, it doesn't matter. Go to settings, plugins, search up Digma, and it will pop up there, and you can install it from there.
Perfect.
And then there is another option, which is we have our beta programming. And it's kind of sounds weird. Why do you have a beta when you already have a product out there? But I think products should always be in beta.
Yeah.
And the beta program for us are users who are not just interested in being end users, who want to contribute, who want to provide feedback, who are interested in this idea of continuous feedback and how it can apply to programming and how they can actually enrich the community with their ideas. So we have, if you are interested in becoming a part of the beta, we can provide a link. It basically, you'll join our Slack group, you'll have access to some of the meetings and some of the projects, and you can either contribute to some of the open source projects or just give us more feedback about your own experiences and kind of have your ideas become a part of the product.
Mm-hmm. And where can listeners find you on the internet? So on Twitter, for instance?
So I'm Doppelware at Twitter, which is Doppleaware.
Mm-hmm.
And then other than that, I have my own Medium blog page where I'm writing a lot about the topic of continuous
Also
feedback.
Doppelware?
I will send a link. It's under my name, Rob.
Okay. And the last question I forgot, is Digma open source? Is parts of open source? Or what's the idea
Part
behind
of it are open source, especially the front end and some of the things we've done there on visualizing traces. We've also extended Jaeger a bit, and we're going to push that upstream as well. The main reason we decided to close source the backend is because we've had some of the bigger APMs source grabbing, and it felt less comfortable for us to work very hard.
Absolutely right.
Just see it appear in some APM. So we decided to close source it, but again, we were only able to justify it by saying, hey, it's not like we're going to charge developers money. We just want to be able to work on content without automatically sharing it with other commercial vendors who are making money out of it.
And I assume that if a huge company approaches you, you will show them the source code, right? I guess.
Yeah, it's not that, and we're also happy to show it to community members or collaborating with us. It's more just protecting ourselves from being.
Yeah, you're right.
Yeah.
It was a pleasure to talk with you, not only about Digma, but also about your software development point of view. So I really enjoyed that. And thank you, and maybe see you next time, right? Or hear you next time.
Definitely. And if you or the viewers are in the Bay Area, please give me a direct message on Twitter, and I'll be happy to kind of hear more about your experiences, because I guess the stories that I mentioned around kind of how users are using observability and how they're not using it, I'm kind of hearing from all around, and the more I learn about it, the more we can understand the problem, and the more we can kind of work with the community to provide a better way to actually make it practical to use observability. And maybe when we talk again in a year or 2 or 3, we'll already see a lot of people kind of with a little bit of a different paradigm for development that includes more feedback.
Thank you a lot. It was a pleasure.
Likewise. Thank you for having me.